Okay, good morning, gang. Welcome. I am just getting Zoom configured here. I've got a couple little things I need to do, and then we will get started. My name is John Filesticker. I'll be your teacher. Hopefully, if you are here, that means you're registered for MAC2312, which is Calc 2, Section 004. Get out some of this stuff. Some writing implements. We will be on the move. All right. So it is nice to meet you guys. I would appreciate if you can, if you're in an environment where it's possible, to please turn on your camera. I will ask that you stay muted unless you have something to say, in which case you can hold the space bar. Think of it like a walkie-talkie button, hold the space bar to talk. But if we can, let's turn our cams on. That way I get to see you and get to know you a little bit. It really does make a big difference. I want to get to know you. I want you to get to know me. All of that is going to be a big help throughout this semester if we can do it. So thank you guys for doing that. I appreciate it. Of course, as always, be mindful of what's going on behind you and around you. I had a kid leave his camera on, and his roommate was in the back taking dabs. That was a little awkward. So you know, just be aware of your surroundings because these are being recorded. That's the other thing. It's in the syllabus. We're going to talk about it, but these meetings are being recorded and they will be posted to YouTube so you can review them after the fact. All of that just to say it's worthwhile to be aware of what's going on. I do want you to have your cams on. That is something I really appreciate. That way we can get to know each other. But you know, be hip about it. So what you're seeing right now is how I'm going to deliver the lecture notes for the class, right? Think of this document camera right here as the whiteboard or blackboard for the class. Anything that I write here, you should be writing in your notes. So just like a regular class, you want to have your notebook out. If you don't have one, grab one, you know the deal. And anything that I put here should go into your notes. Now, I will always start with a little title card. So this is MAC, this pen is not great. 2312, section number 004, which is Calc 2. And today is the 5th of January, 2022. Sorry, got to get in that habit still. All right. Okay. The other thing I'll always do here is just tell you what we're going to talk about today. So today, it's the first day of the class, so we need to talk about the syllabus. We will do that. I'll try to make it as short and painless as possible. And then we're going to review USub, which is section 5.5. in the textbook, right? Hopefully all of your Calc 1 classes talked about integration by substitution. It would be a tragedy if they did not. But I know that not every Calc 1 class spends the time on that, which they should. And I am aware that from time to time, there are Calc 1 classes that don't even get there. So I'm going to move through that material. I am going to move through it relatively quickly. And then we will be ready to kind of get started on the rest of the material for Calc 2. The other thing that we're going to do, which is sort of review, is section 6.1, areas between curves. That is also something which officially is a part of Calc 1, but again, I know it's not always treated the way it should be, sometimes not even gotten to at all in Calc 1. So that's where we're going to go. We're not going to go back to like 5.2 and define the integral. I'm assuming that you guys know what integrals are. You remember their geometric interpretation and all of that. But we will be beginning with USub. Before we can do that, though, of course, we need to do the whole syllabus thing. So let me walk you through the Canvas course. We can talk a little bit about WebAssign and how the class is going to run. We'll go through the policies and grade system for the class, and then we'll get into the mathematics. All right, here's the Canvas class. You made it here, which means you made it there. So everybody has seen this, I assume. I did update the link to the syllabus here because that syllabus was missing one little piece of critical material. But before we get to that, of course, my name is John Filesticker. You can call me John or Professor John or JP or Professor Pete. If you do want to be brave and try to pronounce that last name, it's file sticker, kind of like a sticker that goes on a filing cabinet, but I won't hold you to that. It's okay if you don't. Class meetings, of course, are Monday, Wednesday, Friday from 11:10 a.m. Is that right? 11:10 a.m. Oh, that's right, because they pushed this back a little bit to help accommodate an earlier class that I have. So we're starting a little bit early today. That's okay. I'll turn on my timestamps. There we go. Yeah, all right, that's okay. We're getting a bit of an early start today. I forgot, that's my fault. I forgot that we're starting at 11:10. So usually we'll begin at 11:10 and we'll get out at 12:25. I'll let you go a few minutes early today to compensate for the early start. Fabrice, that's a good question. Let's talk about that after class for just a second. All right, office hours for this class are all going to be online unless you schedule an in-person office hour. You can do that. I am on campus this semester, Monday, Wednesday, and Friday, early in the day. But the regular office hours, the sort of standing office hours, will be Monday, Wednesday, Friday from 1 to 2 p.m. So if you want to join that office hour on one of those days at that time, you just click this link and it will launch a Zoom meeting. On Tuesday and Thursday, I'll have an office hour from 11 a.m. to 12 p.m. Same thing. If you want to come to that office hour, just wait for that time, click this link, and it will launch the Zoom meeting. The final exam, I'd like everybody to put this in their phone right now, is on April 27th at 10:30 a.m. So go ahead and get out your phone. I'm not going to, you're fine, get out your phone. Open up your calendar app or whatever it is that you use to keep track of dates and important things. Wednesday, the 27th of April at 10:30 a.m. is your final. That's not our normal class meeting time, obviously. So you want to make sure you've got an alarm, some notifications, whatever it's going to take to make sure you show up on time for that. In this class, we'll be using WebAssign for the online homework. All of the homework is online, and WebAssign is the system we use to do that. And we will talk about that a little bit more here in the syllabus. Before I launch the syllabus, I just want to point out tutoring is really useful, right? And the tutors here at Santa Fe are always improving, always getting better. They may not be perfect at every single thing we're going to do because this is Calc 2, and a lot of people here, that's their last math class. So getting tutors at the community college level that can effectively tutor Calc 2 is a challenge because usually they're ready to go after they finish Calc 2, whatever is next in their lives. But there are tutors there which are good. And if you're having trouble with something, talking to them is a good idea. I can specifically recommend Alejandro in the Learning Commons. He's a great tutor. To actually get to the tutoring, you will click that link, come down here to Math and Statistics. They have the hours listed, right? In person and online, online only. And then if you're in one of these hour sets, you can click this link. And then click Math, Science, and Business. And that will launch a thing here. So you click this guy and it'll take you to the waiting room. So I strongly encourage you to use the tutors. They will be helpful, especially in the beginning part of the class. Almost all of the tutors there will be very capable of handling those things. This little introductory blurb is just what you would think it is. I want to be your buddy. I want to help you guys out. Please take advantage of that, right? So I answer emails religiously. I try really hard to stay on top of any sort of communication. So if you're struggling, if you're stressed, if things are going great, if you're just curious, anything like that, if you have anything you want to talk about, ask about, think about, anything that's keeping you up at night or bugging you while you're in the shower, don't hesitate to reach out and have a conversation about it, because the whole point of this is that I'm pretty good at mathematics, and I'm happy to help you get to a place where you understand at whatever level you need to understand for this class. Of course, there's going to be a bar that you need to get over, and I'm certainly willing to help you with that. And also, if you have curiosities or anything that you're wanting to explore beyond the class material, I'm more than happy to do that. A little bit about myself, I guess. I did my undergrad at UF. I started at a community college, right? I dropped out of high school. I actually failed Algebra 1 3 times in the public school system, once in 8th grade, once in 9th grade, once in 10th grade. So don't feel bad if you struggle from time to time, right? That's totally normal. Dropped out of high school in 10th grade, went back to college in my mid-20s at a community college, then transferred to UF where I majored in math. And then I started the UF graduate program back in 2013. Did some research there in analytic number theory and enumerative combinatorics before leaving in 2016 to come over here to teach. So if you've got questions about programs at UF, I'm fairly familiar with those. And of course, anything mathematical, I'd be happy to help you with. My specialty is analytic number theory. So using calculus to answer questions about whole numbers is kind of kind of my particular wheelhouse. But anything you want to talk about, happy to talk about it, and especially stuff that's related to the class, whether it's stuff, organization stuff, grade stuff, and definitely the math stuff. I want to hear what you have to say, whether it's positive, negative, concerns, happy, anything like that. Please keep the communication channels open. The best way to get a hold of me is using Canvas messages. Those forward to my email automatically, and they also tell me like what class and section you are in. So if you want to reach out to me, sending me a Canvas message is the best way. The next thing I'd like everybody to do is to please save a copy of the full syllabus. So you can click this link in Canvas, and you will be prompted to save, download the file. Save it somewhere on your computer. You will be able to find it in the future. You really want that. All right, I'm not going to save a fresh copy because I already have one here. So here's your syllabus, and we're going to talk through this quickly. All right, the obvious stuff is here. This is the syllabus. This is section 004. My name is John Filesticker. My physical office on campus is 031D. It is downstairs on the north side of building A. So if you go in building A through the concourse, turn left, go down the stairs, there's an office unit there. I am in 31D. My email, this is a mail to link. You can click this to email me, but again, Canvas messages really are the best way to get a hold of me. This is my office phone number. It is set up to forward to my cell, so you can call this pretty much any time to get a hold of me, but again, Canvas message is preferred. Class meetings, obviously you know this, Monday, Wednesday, Friday, 11:10 to 12:25. Office hours are Monday, Wednesday, Friday, 1 to 2, Tuesday, Thursday, 11 to 12, and those are the Zoom office hours. If you want to do an office hour outside of those times, we can do that. If you want to have an in-person meeting, we can do that. Just send me a Canvas message and we will arrange it. You do not need to make an appointment to come to the regular office hours, but if you want to meet outside of those times, or if you want to meet in person, we do need an appointment for that. The final exam again is Wednesday, April 27th. Please put that in your calendar. It is at 10:30 a.m. and it is a 2-hour test. We'll talk more about that when we get close. The textbook we're going to use for this class is Stewart's Calculus, which is a classic. It is a good book. Here it is. Show you the cover. That's what it looks like. It is important that you have the early Transcendentals version. You will have access to the electronic version of the text through WebAssign. So once you get into WebAssign, there will be an option to click a little link there to go to the e-text, they call it, or ebook. I forget one of those. It's the same thing as this PDF. It's just online, so you view it in your browser. If you want a hard copy of the book, I think it is nice to have a hard copy of the book. It's certainly not required. You can get an older version. You can get a 7th edition. There's now a 9th edition, so the 8th editions are starting to show up in like used bookstores and consignment shops and stuff. So if you want a hard copy of the book, by all means, grab one. If you're having trouble finding a copy of the book that works for you, whether you want an electronic copy or a hard copy, reach out to me. I have this PDF. I don't mind sharing that if you would like it. Also, you'll have an electronic copy in WebAssign. Like I said, hard copies can be found. I can help you find a hard copy. Just in case, the first place I would look, if you're hunting for a hard copy cheap, would be here. On abebooks.com, ABEBOOKS. So here's a student solution manual for the 4th edition, right? There's lots and lots of stuff you'll find, and many of these can be useful. Here's the full thing. We've got it for, let's see, $509. We can definitely find it cheaper. Yeah, here we go. The single variable calculus. This would contain everything you need. You can get a hard copy for 40 bucks, right? So if you want a hard copy, I think that's a great thing to do. They can be found cheap. This website again is abebooks.com, ABEBOOKS.com. You do not need a hard copy, but if you want one, that's where I would look if I were you. All right, back to the syllabus. One thing you will need for this class, the only thing that you are absolutely required to buy for this class is a WebAssign access code. I know it kind of sucks. Nobody likes paying to do online homework. You can get a multi-term access code if you have one of those from the past. That's still working. That's great. But you do need to get an access code for WebAssign if you do not have one yet. The information you need to register for our class in WebAssign is this class key, SF College, space 6144, space 9972. Even if you don't have your access code, you can use this class key to register for our class in WebAssign. Just kind of go through the normal process. I'll show you here, right? So launch WebAssign. Oh, I'm already signed in. Yeah, so what you'd do is you'd go here to enter class key. You would paste the class key from our syllabus here, and hit enroll. This would be it. You'd hit continue. It will ask you for the access code, right, which is separate from the class key after you enroll in that class. If you don't have your access code yet, you can scroll down on that page to a little gray link that says click here to use temporary or trial access. That will get you in for 2 weeks. But before the end of that 2 weeks, you need to get your access code and you need to enter it. It is important that everybody enrolls in WebAssign today. Right? Don't wait for your access code to come in. I understand financial aid hasn't gone out yet, all of that. Please get in there using the trial access. If you don't have your access code yet, that's fine because there is already a homework set up for you here, right? And we're going to start talking about this math today. That homework set is due next Monday at the start of class. We'll talk more about that in just a second. So please, everybody get into WebAssign today. Even if you don't have your access code, all you need is the class key here. That will get you into the class. And then anytime in the next 2 weeks, you can get your access code and enter it there. I think the access codes are about $100. You can sometimes find them cheaper if you shop around. I know if you're going to use financial aid to get that ahead of time, like before they give you the cash, you have to do that at the bookstore. But if you can swing it, there are some other places that'll save you like $20. Look on Amazon, look at other places online. You can search for like cheap WebAssign access code and maybe find some third-party sellers. Just do your research before you buy from any place that looks at all sketchy. Okay, calculators. You do not need a calculator for this class, right? A calculator is not necessary for this class. I won't be using one as we go through the material here, and I'll always try to give you an idea of how far I want you to simplify, what form I want your answers in. Generally, the form that a calculator will give you is not the form I want your answer in. So the only really utility for a calculator in this class is to check your work, right? If you're not sure that you did an arithmetic operation correctly, you're welcome to use a calculator to check your work. When it comes to the tests, the only calculator you're allowed to use is this one. Has to be exactly this one, the TI-30X2S. There are other TI-30s that are not okay, so please make sure it is exactly this calculator. You can get these dirt cheap. They're like $12 at Walmart, brand new. You can find them lying in the streets of Gainesville because Gainesville, I saw one on the floor at a cell phone shop the other day. These things are literally everywhere because they're the required calculator for all the calc classes here and at UF. So please, TI-30X2S if you want one, right? But you do not need one. Definitely no other calculators are allowed. Specifically, nothing that can do symbolic manipulation. If it returns the sign of pi over 3 as the square root of 3 over 2 instead of a decimal, that's out. If it can do any sort of graphing, that's out. Definitely if it can calculate derivatives and antiderivatives like the TI Inspire, that is out. So the only calculator that is kosher is the TI-30X2S, and I strongly recommend practicing your homework and study guides with these. That way it's not like a sudden shift when it comes to the tests, because this is the only thing you can use on the test. The other thing you're going to need, obviously, is a computer with an up-to-date web browser, good internet access, and a functioning webcam. Clearly, for Zoom lectures, you need those things. Also, for the proctoring, the exams, you will need these things. The other thing you're going to need for the tests is a smartphone. I know everybody has one. You're going to need that, and you're going to need to install Zoom on your phone for the tests. I'll talk a little bit more about the proctoring system when we get closer to the first test. But just heads up, you need a computer. Obviously, you need internet access. Obviously, you need a webcam, and you also need a smartphone. This is Calc 2, right? Course description. This is Calc 2. It's the second calculus class. There's 3 of them. This is the second one. We're going to focus on integrals for the first chunk of this class. Stuff you can do with integrals and how to evaluate integrals. We're going to learn a lot more about integration than you learned in Calc 1. We're going to go quite deep there. After that, we're going to talk about convergence, sequences and series, which are these mathematical objects that kind of go on forever and sometimes come out really nice, sometimes don't come out nice. After that, we're going to talk about power series, how to represent a function as a big, long polynomial. There's a lot of kind of challenging notation there and some challenging concepts. If you stay on top of the homework, if you attend every lecture and you stay on top of the homework, working it every day, you will be okay. All right. This class, I know, has a reputation, and that's for good reason. The pass rate in a Calc 2 class is, it's not rare to be below 70%. It's not even rare for it to be below 60%. But the reason for that is largely discipline. So you must be disciplined in this class. There's no room for like procrastination here. You got to work on this stuff every day, and you got to communicate with me. If something is feeling hard to you, if you're not getting the problems right, the first or second try on the homework or the first try on the study guide, that means you need to come to office hours and talk with me. And trust me when I say I'm happy when people come to office hours. I'm disappointed when people don't come to office hours. So please come talk to me. I will help you. I promise. I'm happy to help you. Please do not suffer in silence. Some of these things, especially the sequences and series, power series, series representation of functions, this stuff is what gives the class the reputation it has. So make sure all through the class, but especially when we get here, that you're communicating a lot with me about how you're feeling with the material, and we can work together to make it go well. There is an official list of course objectives published by the department. If you want to read those, they are here. I'm not going to do that. Technology policy, basically just be polite, right? Don't distract other people. Obviously I'm not worried about you scrolling snaps to book in the back of the room and making noise because this is Zoom. But the other side of that coin is during these Zoom meetings, if you're going to chat, that's fine. You can use the chat. Using the chat is good. But make sure you keep it focused on the material that we're talking about in the meeting. And please don't message people on other platforms during the class meeting. That can be very distracting. There's a question here about the WebAssign access code. I'm not too sure, Kim. So the question was, which of these WebAssign access codes should you get? Cengage Unlimited eTextbooks or Cengage Unlimited? I'm not 100% sure what the difference is between those things. They recently changed their system and their nomenclature. So if you're uncertain what access code to buy, shoot me a Canvas message or an email, and I will get back to you after talking to our rep. But what you're looking for is just the basic access code to get in and do the homework. Okay, attendance, Zoom is pretty convenient. It will take attendance automatically. Just make sure you're signing into Zoom with your real name or your name as it appears on your Santa Fe ID. That's what matters, right? Is that the name here in Zoom matches up with my roster. That way I can mark you as attending. There is no attendance component to the grade, but if you want your financial aid money to disperse, I need to mark you as having attended, which means you need to show up and also use the same name that's on your Santa Fe ID in Zoom so I can mark you appropriately. Of course, missing class is really bad, right? You're paying for this class. This is where you learn the material and then you go practice it and develop the skills on your own. Please don't miss class. If there's one predictor for success in this class, besides doing the homework, it's coming to the lectures. So come to the lectures, engage, talk, please. Makeups, I'm really loose on this. If you need a homework extended for whatever reason, just push the little button in WebAssign saying request an extension. I'll grant it as soon as I see it. I go through every day and clear those out, so you'll never have to wait more than 24 hours. Tests are a bit more complicated. If you know you're going to miss a test, like you're going to be out of town or you've got something coming up that is unavoidable, let me know ahead of time. If you miss a test for some unforeseen reason, just reach out to me as soon as you possibly can, and we will schedule a makeup exam for you. The makeup has to be done within 1 week of the original test date. But that's it. So, yeah, if you miss something, you need an assignment extended, or you miss a test, just, again, communicate with me, right? Keep the communication going and we'll work it out. If you miss something and don't communicate with me, then we can't make it work out. So please talk to me. Homework and study guides. Every week there's going to be a homework set. It's going to be published on the first day of that week, usually Monday. Today, of course, we're starting on a Wednesday, so I published the homework set for you this morning. It will be due at the start of class the next day, the next week. So your first homework set is open now, and it will be due at the start of class on Monday of next week. There are also study guides. So before each test, about a week before each test, I will post a special homework set to WebAssign titled Study Guide 1, Study Guide 2. You need to answer those questions in WebAssign, but more importantly, you need to write out solutions to those questions on paper, and you need to submit the scans of those solutions to Canvas. So it is the case that we will need to scan things in this class, and there are two tools for that I recommend, whether you're on Android or iPhone. These are my two preferred tools. So Cam Scanner and Adobe Scan are both really good. They're both free, and they both produce good, high contrast, legible scans. So either Cam Scanner or Adobe Scan. If you have an iPhone instead of an Android, you can use the Notes app. It also does a good job of this, but please don't take pictures like a JPEG and then try to convert it to a PDF. That always comes out like crap. So download one of these apps or learn how to use the scanning component on the Notes app. Either one is fine. Yeah, this is the Cam Scanner app. I think the free version here limits you to a certain number of scans or a certain amount of storage, something like that. There's a paid version. I don't know. I wouldn't bother with the paid version. The free version is fine. Adobe Scan has become more popular in recent months. That's fine too. But make sure you have a tool on your phone that allows you to scan. If you have a physical scanner, like a flatbed scanner at home, use that. That's dope. But if not, those are the tools I would prefer. Every time you submit an assignment, like a written work thing, it will need to be scanned and uploaded to Canvas. I mention that now because in order to get credit for the study guides, those special homework sets that come before the test, you need to scan and submit your written work, right? Completing the assignment in WebAssign will not get you the points for the study guide. You need to scan and submit the written work. And ideally, you'll scan and submit it as soon as you can after I publish it. So as soon as I publish the study guides, you should start working on them. As soon as you finish it or get as much of it done as you can, scan that, submit it on Canvas, because then I can get in and mark it up and give you comments and feedback. The idea there is that I get to see your written work before the test. And that way I can tell you this looks great, or here you need to make some changes, or I noticed you made this mistake a few times. Be careful about that on the test. So study guides, remember you need to scan and submit that written work to get credit. They're due on the day of the test, but if you can submit them sooner, I can give you feedback. And that's really what we want with the study guides. So as soon as the study guides are published, work them, scan them, submit them. They're not graded for correctness. They're only graded for completeness. So as long as you attempt each problem on the study guide, you will get full credit, 100% on the study guide. Again, the purpose there is just for me to see your work before the test and to give you some feedback so you're not surprised by how I grade when the test comes around. Technically, this class does have a lab, right? Monday, Wednesday, Friday. Mondays are the lab days. Because this is a Zoom class, there's not going to be a big difference. It's not like we're going to a different room where there are computers. You have computers, but some Mondays we will do lab activities where I'll ask you guys to download a worksheet ahead of time and work independently using Desmos or something like that. 3 midterm exams, 1 final. The final is cumulative. Because this is a hybrid class, the exams are going to be in Canvas. They'll be structured as Canvas quizzes, and we'll be using HonorLock to Proctor. In addition to HonorLock, we're going to be using Zoom. So you're going to be on your computer using HonorLock, and then on your phone, you will sign into a Zoom meeting on that day. You'll set up your phone somewhere on your desk where I can see your hands, your paper, your lap. You'll leave your cameras and microphones on in Zoom so I can see what's going on there. HonorLock will record your screen, your webcam, and that way we can minimize the cheating that takes place. We'll talk more about that in a second. The final exam, again, 4/27/22, 10:30. Please put that in your phone. Don't forget, don't forget, don't forget. Recording notice. This class is on Zoom. I record the lectures so I can post them to YouTube. That means you are being recorded right now, and this will go up to YouTube. So please don't take bong rips in the background. Don't walk around in your underwear, all the obvious stuff. Important dates. These are some things you want to be aware of. Obviously, classes start today. The last day to add a class is the 7th. The last day to drop and get your money back and nothing on your transcript is the 11th. We're closed for MLK's birthday on the 17th of this month. Spring break is the 2nd week of March. The 23rd of March is the last day to withdraw from the class. And we'll look at the schedule in a little bit. This is just after exam 2. So if your exam 2 comes back and you're like, shit, exam 1 and exam 2 are both terrible. There's no way for me to pass. Last chance to get out of here without a grade is the 23rd. If you want to withdraw after that, you have to go through the petitions process. So you want to kind of stop and assess your position in the class on that date. Last day of lecture is the 22nd, final exam, again, the 27th, and your grades will be posted to eSanta Fe by the 3rd of May. Here is the grade breakdown. There is homework in WebAssign, 45 points, a little less than half of 1 test, 8% of the grade overall. The study guides, and this is the written work that you submit to Canvas. Remember, the stuff that you actually send me, not the completion in WebAssign. The written work for the study guides that you send me, worth 25 points each, cumulatively are worth about 13% of the grade. The bulk of the grades come from the tests. So there's 3 midterms. Each one is 100 points. The total from the test is about 53%. So more than half the grade comes from the midterm exams. And then the remaining 26% comes from the final. So you see more than 3/4 of the grade is proctored tests. So you really want to take those tests seriously. You need to prepare for them. You need to really, really grind and make sure you're ready for that shit. The other stuff, this is just here. The only reason there's any graded component to these is to encourage you to do them. So think of the grade in this class as coming from the test. The homework and study guides are really just there to help you get ready for the tests. Grading scale is the normal one. 90 to 100 is an A, 80 to 90 is a B. The top 3% in each category earns the plus designation. And if you land within 1.5% of the next letter grade, I will bump you up, right? So an 89, that's an A. 88.6, that's an A. That's the system. The next page in the syllabus, this is just like boilerplate syllabus stuff, all the things that Santa Fe requires us to have in here. Don't read the stuff if you want to. Here's the thing I really want to talk about. So we've been doing this online thing for a while now, right? Since like April of 2020, we've been doing something like this, at least for some of the classes. And I know that shit been slipping, right? Like cheating is on the rise. I get that. I understand that the quality of instruction has not always been what it should be. My wife is actually a student here at Santa Fe right now. She went back to school a couple of years ago and she's working on her degree. I've seen some really shitty online classes. I've seen some really good online classes. Pretty universally among all of those that I've watched my wife take, I've seen massive amounts of cheating, like way more than I've ever even heard of in an in-person class. That doesn't happen in my classes. Now, let me rephrase that. That does happen sometimes in my classes, and I catch you, right? For example, last semester in one class on one test, the final exam, 6 people, right? Caught 6 people cheating, and it was not hard to tell. And all through the semester, I had been making notes on their stuff saying, this looks a little suspicious. This is very similar to what Mathway gives. Like, I will give you a little warning the first time I see something like that. The second time, it's just straight to Dan Rodkin, and I'll let the conduct board sort it out. Please, please don't fucking cheat, all right? Just like you, I have Mathway, Photomath, Symbolab, Desmos, all that shit on my phone. I run my own tests through them. I know what the output from those apps look like. I also know what a real solution looks like. They're not the same. Don't cheat. If you cheat, I will catch you. I swear to God, I will catch you. And then we have to have that whole unpleasant conversation where I send you off to Rodkin, and it's just not fun, right? It's not fun for any of us. Your grade suffers. The penalties are as follows. The first time I catch you cheating, you get a 0 on that assignment and a letter to Rodkin's office. The second time I catch you cheating, you get a ZF in the class and a letter to Rodkin's office. If you are caught cheating twice and the conduct trial agrees that you cheated those 2 times, then there's also a possibility you'll be expelled from the institution. A ZF on your transcript is really bad, just to be clear. ZF is different from a regular F. It means an F for academic misconduct, and that can kill your transfer goals. It's just really, really bad. I don't want that shit. It's so important that you don't cheat, not just because I want you to learn, but also because it devalues the degrees. This is the thing that I'm trying to convince my colleagues of, that they really need to be hard on cheaters, because if it becomes known that people who graduate from this college cheated their way through classes, then an A in this class doesn't mean anything anymore, right? It doesn't mean anything to the institutions you might try to transfer to. It doesn't mean anything to the places where you might apply, whether for internships or jobs or whatever down the road. We want to keep the value of those degrees up. I want you earning an A in my class to really mean something down the road. And the only way we can do that is if we keep cheating down. So I know it's inevitable that some people will be tempted to cheat. I know that you've maybe gotten away with it in a previous class, and I'm not saying this to any particular person, just in general. I know it's been easier to cheat lately, right, over the last couple of years. It's not like that in this class, right? You may be able to get through the test and have a paper hidden somewhere or something like that, or scan things on your phone. But I will notice, because you have to submit your written work for all of my proctored assignments. I look through it very, very carefully. And if I see anything even remotely suspicious, I go through both the Zoom recordings and the honor lock recordings with a fine-tooth comb. When people cheat, I catch them. So please don't cheat. The other side of that, and this is how I'm going to, that's the stick, right? I will beat you if you cheat. The carrot is, if you are tempted, right? If you're feeling like you're up against a wall and you don't know what to do, there's a test coming up and it's just not going to go well, and you're starting to think about where you can hide the cheat sheet or how you can have a second phone in your lap or some shit like that. Instead of doing that shit, send me an email saying you're stressed, you're worried, the test isn't going to go well, and I will work with you. I will move the test date for you. I will do extra office hours with you. I will meet with you in person to solve problems. Whatever you need to make that shit go well, I'll do it, right? I'll work with you. My goal here is not to punish you for sucking at math. Everybody sucks at math at the start. Sucking at something is the way you get good at something. You got to be crappy at it at first and then work at it and then you get good at it. I will work with you, right? I'll do whatever it takes to get you to the place you need to be. But just please communicate with me. And if you try to cheat your way through, then I will do everything I can to fry you. Not because I like you if you cheat, but because I need to preserve the value of your degrees. All right, don't cheat. Don't cheat. I'll catch you. I swear to God, whether you copy or use an app or Google or something else, I will catch you. Please don't do it. If you're tempted, just send me an email. You don't have to say, I'm planning on cheating, so can I do something else? Just say, I'm stressed, I'm worried. Then we'll move the test. We'll find something else. We'll get you extra help, whatever it takes. Okay, I promise. Here's the schedule. So the first week, we're going to talk about substitution. This is U sub, then areas between curves, and then average value. Next week, we're going to talk about volumes. There's a couple different ways to calculate volumes of three-dimensional solids using integrals. We'll learn how to do that. And then we're going to talk about this concept from physics called work. After that, we're going to begin chapter 7. Chapter 7 is all about methods of integration. So you know how to integrate some functions from Calc 1. There are a lot of other functions that we don't know how to integrate yet. We're going to start learning how to do that. And then after we get through chapter 7, we're going to have our first test. After that, we begin kind of the middle third of the course, which is all on convergence. There are a few different kinds of objects that we can talk about converging or diverging. I'll explain what those terms mean and everything as we get there. But that is test 2. Test 2 is all about convergence, and it will be right after spring break. I'm going to give you a little project to work over spring break so you don't forget all of this stuff. Then we're going to come back, we're going to review a little bit, and we'll have test 2. After that, we're going to start talking about power series. And these are infinitely long polynomials. We'll learn how to represent a function, or at least approximate a function, as an infinitely long polynomial. Then we will talk about this theorem called Taylor's theorem, which is a means of calculating. Sorry, one moment. Okay, sorry about that. So power series, infinitely long polynomials. We'll learn how to write functions as power series. Then we'll talk about Taylor's theorem, which is a special rule for how to get a power series for a function, some applications, and then we're going to move on to these sort of disparate topics of parametric curves and polar coordinates. Then we'll have exam 3, and that is the class. After exam 3, if we need to, because we've used some time elsewhere in the semester or moved things around, I may shove a couple extra topics into this last week. Otherwise, we will just review for the final, and then the final again, and for the last time is on the 27th of April. All right, I know that was a long and boring spiel. Does anybody have questions about the syllabus, class policies, course schedule, anything like that? Okay, I'll say it just one more time. Please save a copy of the syllabus somewhere on your computer where you can find it. I strongly recommend creating a folder on your desktop for this class. First thing that should go in there is a copy of the syllabus saved so you can refer to it, because there are lots and lots of questions about the class that can be answered just by looking at the syllabus. Okay. We talked about wet assign a little bit. Let me just show you what that first homework set looks like. Here it is. Wow. All right, you see the homework set, about 30 problems, maybe a little more. Yeah, 40 problems, 43. Plenty of problems here, right? And you've got a little less than a week to do it. Most of it should be review. But I know winter break, shitty Calc 1 class, whatever, some of this stuff might feel a little rusty. So we're going to begin talking about U sub. That's what we're going to do for our first few problems today. In addition to U sub stuff in here, there's some areas between curves stuff, some kind of questions about how integrals relate to algebra. and then questions about average value, which is a concept that we haven't introduced yet. I'll introduce that next time. So what I'd like to do now is come back over here to our little blackboard. Remember, everything I write here needs to go into your notes. If you have a question, please stop me, right? Remember, you can hold spacebar to talk. It's like a walkie-talkie. Just shout out. If you got a question, don't be shy. Just shout out. There's also a raise hand feature in Zoom here. I'll try to watch for that, but don't be shy. If you'd rather type, I'll watch the chat also, but definitely prefer you just talk, right? Just pretend like it's a regular class. We're all here together. So. A lot of people call this U sub. I'm going to use a different letter. I'm going to use the letter Z most of the time. I think our first problem, I'll use the letter U just to try and make it familiar with what you've seen in the past, but there's a good reason to use other letters. Down the road, we're going to specify the letter U to mean something else. Substitution is the backwards chain rule, right? So you remember that when you're differentiating a function, if there's like an outer function and an inner function, it's a composite function, you need to use the chain rule to differentiate. U sub is the antiderivative version of the chain rule. That's all. You've seen this before, so I'm just going to begin with examples. Every time I start an example, I will write EG. That stands for exemplus gratis. I forget, my Latin is terrible. It's the Latin abbreviation for example. If I want to integrate the function square root of x minus 1, right? This is an indefinite integral. It is an integral without any bounds. The symbol on the left here, this big long S, that's what that is, the Latin letter S, it's just stretched out. If you see some numbers here, below and above that symbol, that is a definite integral. If you don't see any numbers there, then that is an indefinite integral. And what we mean there is we're just asking for the most general antiderivative of the function inside, right? So this thing inside is called your integrand. It is the function you're integrating. The big S is called your integral symbol. And the thing at the end here is called the differential. dx or dt or dy or dz is called the differential. In a definite integral, an integral with bounds, this thing has a real geometric meaning. It's like a little thickness, right? And you can think of this thing as being a little height times a little thickness, which gives a little area. And what the integral does is it sums, that's why we have an S there, sum, S-U-M, adds up all those little areas to give a total area. But like you learned in Calc 1, when you talk about the fundamental theorem of calculus, the indefinite integral is just asking for the most general antiderivative. A few things. If this was just the square root of x, then we could apply the power rule. What the power rule says is if you're integrating just x to the n dx, this is x to the n plus 1 over n plus 1 plus a constant. And that's for all n except -1. Right? If you're integrating x to the -1, that means you're integrating 1 over x. X to the -1 is 1 over x. That has a different antiderivative, naturally, namely the natural log. So the challenge with this guy is that it's not just the square root of x. If it were just the square root of x, that is x to the 1/2, which is a straight up power of x, and I could apply my power rule. A little note. And I'll try to color code things like this throughout the semester. The square root of x minus 1 is x minus 1 all to the 1/2. Right? The square root is the 1/2 power. But that is not the same as taking the square root of those things separately. Right, this, let's come over here, sorry. This and this are very different. And it's not just the 1/2 power. Powers in general don't distribute like that, right? Like if I had x minus 1 squared, You'd have to FOIL that out. That's not x squared minus 1 squared. In the same way, x minus 1 to the 1/2 is not x minus x to the 1/2 minus 1 to the 1/2. You cannot do that. So I can't split this up. That's what I'm saying here, is that you cannot split this up as root x minus 1 and then integrate each of those using the power rule. We need to do something else. The something else is a substitution. So what we said at the start was that if this was just the square root of x, then I could use my power rule. Because it is not just the square root of x, I want to make a substitution. And I'll use the letter u here just this once. We're going to let u be x minus 1. This is a change of variables. Right? I'm going to rewrite this integral, which is right now in terms of the variable x, in terms of this new variable u. And in order to do that, I need to rewrite all the pieces. I need to rewrite the integrand, I need to rewrite the differential, and if there were bounds, if it was a definite integral, I would need to rewrite the bounds also. Just thinking about this substitution, I can see that this piece right here is going to become the square root of u, because u is x minus 1, the square root of x minus 1 is the square root of u. I also need to rewrite the differential. And the way you do that is by coming here to your substitution and taking differentials on both sides. So hopefully you remember what a differential is. It's fairly straightforward. You just differentiate on both sides here. On the left-hand side, we're going to write du. On the right-hand side, I'll take the derivative of x minus 1, which is 1 minus 0, and then I write dx. Slightly different than a derivative, the concept of a differential. This is something that is discussed in Calc 1, but again, not always as well as it should be. So the differential of u is du. The differential of x minus 1 is 1 minus 0 dx. And that dx at the end is important. If you skip writing these, I will take off points. I can simplify that a little bit. 1 minus 0 is just 1. So this is the same as saying du equals 1 times dx, so just du equals dx. That is all the stuff we need to make our substitution in that integral. And I recommend putting it in a little box like this, right? That gets it out of your workflow for the integral and helps you keep things organized. When we do that, my integral becomes the integral of the square root of x minus 1. Well, that's just the square root of u. And then dx, I also need to replace by its equivalent expression in terms of u. But here I see that du and dx are equal. So that dx really is just du. Now we look at this as a fresh problem and we ask, is this easier or harder than the original problem? Well, here I couldn't use my power rule. Here I can use my power rule. So it's gotten better, which means we did the right thing. Yay. Since I want to use my power rule, I will rewrite this as a power. The square root of u is u to the 1/2. So I'm integrating u to the 1/2 du. And now according to that power rule, the integral of u to the 1/2 du, integral of x to the n dx, you just add 1 to the power and divide by that new power. So if I add 1 to 1/2, 1/2 plus 1 is 3/2. And I divide by that new power. And then because it is an indefinite integral, we add our plus c here. Any questions so far? Okay. And don't be shy if you have questions. If you're wondering about something, I promise you so are 10 other people that are too shy to ask. I'm going to continue over here. There's two things I'd like to do with this expression before we can call the problem done. First thing, this ratio, this fraction, can be simplified quite a bit, and I would like to simplify this fraction. The other thing, because this is an indefinite integral, I asked, what is the antiderivative, the most general antiderivative for this function? That should be a function of x, right? Your answer here should be given in terms of the variable x. So we need to go back to the original variable. So what this is going to look like, dividing by 3/2 is the same thing as multiplying by 2/3. And then u to the 3/2, u is x minus 1. So that's x minus 1 to the 3/2 power. And then we have our plus c. So this is what your final answer should look like for this problem. I recommend using punctuation. I know it's mathematics, but you'll see later in the semester we'll be writing in full sentences. There are real reasons to use punctuation here. So that's the end of that thought, right? What is this integral? Oh, well, I'm going to substitute u equals x minus 1. That means du is dx. The integral becomes the integral of root u, which is the integral of u to the 1/2, which looks like this according to the power rule. And then we go back to our original variable, thought done. If you want to check, how do you check an integral? How do you check if you did the right thing? Besides plugging into Mathway or whatever.
You take the derivative, right?
Yeah, very good. Katie nailed it. We take the derivative. So if I want to check that I did the right thing, I should take the derivative of 2/3 x minus 1 to the 3/2. And you could include the plus c here if you wanted. Now the rules for derivatives, constant multiples pop out. And you can differentiate sums one piece at a time. So I'm taking the derivative of this and adding it to the derivative of this. And then the 2/3 is a constant multiple, so it can pop out of that first derivative. He just comes along for the ride. The derivative ddx of x minus 1 to the 3/2 is a chain rule derivative. So that power comes down, 3/2 x minus 1 to the 3/2 minus 1 is 3/2 minus 2/2 is 1/2. And then the derivative ddx of the constant c is 0. Looking at the fractions out front, the 2's cancel, the 3's cancel. So when that all cancels, this just becomes a 1. X minus 1 to the 1/2 is the square root of x minus 1, and 0 is 0. So this is good, right? That was the function we were trying to integrate. So you can always check your antiderivatives. You can always check your integrals by taking a derivative. Any questions on this guy? Okay. A couple more examples like this. I'd like to integrate indefinite integral. I'd like to integrate the cosine of pi x. As before, I want to identify an inner function and then substitute for that, right? This is like a backwards chain rule. So what is the inner function here?
Is it pi x?
Yeah, pi x, right? Normally we think of like cosine theta or cosine x, cosine t. The outer function is cosine, and the thing that's been plugged into that is pi x. So the substitution here, and like I said, I'm going to use a different letter. I'll usually use z. Substitution here, z equals the inner function, pi x. I take my differentials. We always do this before plugging in for our substitution. dz, the differential on the left. On the right, the derivative of x is just 1. So the derivative of pi x by that constant multiple rule is pi. And then we slap on our dx, right? It's the same thing as saying that dz dx is pi. This is everything I need for my little substitution, so I'm going to put it in a box. And over here in my main workflow, I rewrite the integral as the integral of cosine z. But I need the differential, right? We never ever write an integral without a differential at the end, dz, dx, whatever. In the last problem, du and dx were equal. So I just replaced dx by du. Here, dz and dx are not the same thing. dz is equal to pi times dx. So if I want to replace dx by its equivalent expression in terms of the variable z, which is my goal, I should solve this for dx. And we do that by dividing both sides by pi, or multiplying both sides by 1 over pi. Everybody see, if dz is equal to pi times dx, then 1 over pi times dz is equal to dx. So this piece, dx, is going to be replaced by this piece, 1 over pi times dz. And that differential work can get substantially more complicated. This is about as simple as these get. Any questions about where this piece is coming from? And really take a second. If you have questions, this is the perfect time to ask. If you wanted to write it as dz over pi, that's okay too. But I think it's nicer to write it like this because our very next step, remember everything here is multiplied, cos z times 1 over pi times dz. And just like with derivatives, constant multiples can come outside. This is 1 over pi times the integral of cos z dz. Pro tip, cross your z's. That way they don't look like 2's. So now this 1 over pi is out front. I've moved him from inside to out front because he was a constant multiple, and constant multiples pop out of integrals. We focus our attention just on this piece now. That is the indefinite integral of cos z dz. So we're looking for the most general antiderivative of cosine of z. What is that? Who has derivative cos z?
Sine.
Sine, yeah, Quinn, sine of what?
Sine of z.
Very good, very good. The derivative of sine z is cos z. So the antiderivative of cos z is sine z. And this last part is kind of picky, but again, indefinite integral, always write a plus c. So an indefinite integral is not one function. It's an infinite family of functions. It's all the functions whose derivative is the original integrand. Now remember, the integrand is just the name of the function inside the integral. So this is good. This is correct, and it is equal to the line above. Am I done?
Don't you still have to plug z back in?
Very good. Because it's an indefinite integral, the original problem was asking for the most general antiderivative of cosine of pi x. If you ask me what's the most general antiderivative of cos pi x, and I come back and say 1 over pi times the sine of z, you'd be like, what the hell is z? You got to tell your reader, oh, well, this thing is secretly just pi times x. So yeah, we plug back in for z. With definite integrals, we don't do this. We do something else. But with indefinite integrals, we always plug back in at the end. And now that is a complete thought. If you wanted to check, you could. You can differentiate this, and you will get cosine of pi x. Questions on this guy? Okay. Let's try a definite integral now. This is very similar to the first problem we did. We have a square root of x plus 1 instead of a square root of x minus 1. The other difference, of course, is that there are some bounds here. So this is a definite integral rather than an indefinite integral. And definite integrals represent areas. These have a very tangible geometric interpretation. I'm going to pull up Desmos for a second, and I'll do this often to help you see what's going on. What I'm looking for here is this area, right? The red curve is the square root of x plus 1. And when I integrate that from 1 to 2, that means I'm asking for the area bounded by that red curve and the x-axis from x equals 1 to x equals 2. That's this blue area here. The mechanism for solving this integral is very similar to our first example, right? It's a square root with a simple little function inside, so we're going to substitute for the inner function. But because it's a definite integral, the procedure is slightly different. As before, we're going to let our new variable be the inner function. So I'm going to let z be x plus 1. And as before, I'm going to calculate my differential. Now the derivative of x plus 1 is still just 1, so dz is still just 1 dx. All that is the same as before. The difference here is the bounds. So let me come back to Desmos for a second. All right, we've selected our substitution, we've calculated our differential. We know we can use that to get an antiderivative because this is so similar to the first problem. But let me try to show you something neat here. All right, the green curve is the square root of z. That's what I'm going to get when I plug z in here for x plus 1, right? If I integrate this from 1 to 2, I would get this purple area, which is not the same as that blue area, right? The purple area is clearly smaller. So what I need to do, as I go to plug these things in, I'll have integral square root of z dz. But if I integrate this from 1 to 2, it's going to give me the purple area, which is not the area I want. I want the blue area. So what I need to do is change my bounds to find the region under the green curve that gives me the same area as this blue area. How do I do that? How do I change those bounds to make sure that the area I get from my new integral is equal to the area I get from my old integral? Well, you plug the old bounds in here. So my old bounds, the values of x were from 1, right? This lower bound is an x value, to 2. When x is equal to 1, what is z, right? This new integral is in terms of the variable z. So I need to figure out the values of z that correspond to those values of x. And you do that by plugging into the substitution. So when x is equal to 1, z is equal to 1 plus 1, which is 2. And when x is equal to 2, z is equal to 2 plus 1, which is 3. So my new integral is going to run not from 1 to 2, but from 2 to 3 instead. And you need to do this on the test or I will take off points. Just telling you now. Right? So I can give you the grumpy dad look. If you don't change bounds, I'm taking off points. Right? It's important. Otherwise, these are not equal. We want the things we write down that we claim to be equal to each other, right? Don't want to tell lies. So you need these bounds, 2 to 3, not 1 to 2 on your new integral in order for it to be correct. Let's see it in decimals. All right, ready? We want this to be the same as the blue area. There it is. You see it? The blue area and the purple area, if I slide this purple area over, it would become that blue area. It's the same thing. So changing these bounds is necessary in order to make sure that your new integral is equal to the old integral. I know that some Calc 1 teachers say you can wait till the end, plug in the old variable, and then use the original bounds. Fuck that noise. All right, it's sloppy, it's a hack. And what it means is that as you work through your problem, you're telling lies. If you tell me that this original integral is equal to this integral with the bounds from 1 to 2, you've told me a lie. Don't do it. Change the bounds. It's required. Right? I get that some Calc 1 teachers tell you, no, you don't need to do this, you can do it the other way. They're wrong. They're trying to be nice, right? They're giving you a lot of stuff all at once, and they don't want to force you to do too much at once. But now that you've seen this, you've practiced it in Calc 1, it's time to do it right here in Calc 2. This is the right way to do it. The nice part about changing your bounds is that you don't need to go back to the old variable at the end. We're going to take our antiderivative here, and we're going to evaluate it between these new bounds without ever plugging back in for x. Let me show you. Remember, the square root of z is the same as z to the 1/2. So we rewrite our integral as a power. Then we take our antiderivative. Antiderivative for z to the 1/2 is 2/3 z to the 3/2. This is a definite integral, so we don't need to write a plus c, but you do need to evaluate this between these bounds. And there's several notations for this. You can put a vertical line here with those bounds. You can put a bracket here with those bounds. Or you can put the whole thing in brackets with the bounds on the right. Any of those notations is acceptable. This is the one that I like best. And now we plug those bounds in. You always plug in the upper bound and then subtract what you get when you plug in the lower bound. This is 2/3 times 3 to the 3/2 minus 2/3 times 2 to the 3/2. You can factor out the 2/3 if you want. You don't need to. You could leave it like this and I would accept it. This would be full credit. But if you want to, you can write this as 2/3 times 3 to the 3/2 minus 2 to the 3/2 if you want. And there is no way to combine those two pieces. This and this cannot be combined. So this is as far as you can possibly go. Okay. So I really do want to pause for a second here and take any questions specifically about changing the bounds or rewriting this integral. What are we thinking? How do we feel? Anything at all? Could I see you guys know how to use the reacts in Zoom? Could I see a thumbs up react if your Calc 1 teacher showed you how to change bounds in a definite interval? Oh, good. Very good. All right. So a good chunk of us have seen this before. Not everybody, and that's okay. Not every Calc 1 teacher shows it. Some shoot entirely, so it's understandable. Just be aware that in this class, it is a necessary thing. I do have, if you want to explore this, I encourage it, especially if you're seeing it for the first time, go to the modules in that review material module, right? I've posted a bunch of stuff here to help you through each of these sections. None of this is stuff you have to do. None of it is an assignment. It's all just links to things that help explain or show examples. If you look here under the review material module, why we always substitute bounds, why we always change bounds when subbing in a definite integral, you will be taken to this page, which is the best thing I've found for explanations here. They talk about the different areas and how the differential stretches and squeezes the horizontal axis. This is a good explanation, right? It's the same thing as what I showed you here. But you can explore that at your leisure, along with all the other things in there. And I strongly encourage you to do that, especially if you've never seen this before. All right, last call for questions. Everybody comfy with where these numbers came from, where this 2/3 came from, all of that? Anything at all that we're wondering? Don't be shy. Okay, then moving on. I'd like to do 2 more problems. We'll do this as an indefinite integral. Integral of e to the x over 1 plus e to the 2x. If you took Calc 1 with me, this may look familiar. We know we're working on substitution, so we should be looking for a substitution. Does anybody see something they would like to try and substitute for? Remember, you can hold spacebar to talk.
The denominator?
We could try subbing for 1 plus e to the 2x. That's an option. If we do that, though, what is the derivative of 1 plus e to the 2x? Tell you what, instead, let me show you an algebra rule. We'll come back to that. So if I have a power, right, and the power is a product, that is the same as a to the b all to the c, or you could do it the other way. It's the same as a to the c all to the b, because b times c is the same as c times b. So this is an algebra rule that will allow me to rewrite that denominator in a way that kind of shows us what the inner function is here. E to the 2x is the same as e to the x all squared, like this. So now do we see an inner function somewhere? Something that looks like it's been plugged into something else.
Does it have anything to do with arctan?
Yeah, that's a good eye. There's something arctangent-y going on here. There's a suggestion in chat to sub for the numerator. That's actually perfect. I would say it's coming more from this piece. The numerator is actually going to get soaked up by the differential. I'll show you that in a second. It's going to cancel with your dz term. But if you look down here, this is like an inner and an outer, right? Inner, outer. And you could even think of this as like z over 1 plus z squared, where z is e to the x. So the move here is to just sub for e to the x. Subbing for the denominator is not a bad idea. It's a pretty reasonable thing to try, but you'll see that it doesn't work out. And I'll take a quick look at that in a second. But if I sub for e to the x, I have an e to the x piece down here that'll just become z. So this will be a z squared. I have an e to the x piece up here. And when you look at your differential, so before you plug in, always calculate your differential. The derivative of e to the x is e to the x. So dz is e to the x dx. And again, don't forget to write the dx. One reason it's so important to write your dx is because our very next step here is going to be to solve this for dx. Just like I divided by the pi in that second example, I can divide both sides by e to the x, and I get 1 over e to the x dz is equal to dx. And now I go ahead and start plugging stuff in. Plug the differential in first. So I'm going to leave everything else alone. Even though I know what some of it is going to do, we leave it alone at this step and just plug in for dx. Dx is 1 over e to the x times dz. Why is that nice? Because this and this cancel. So now what's left over? Well, I've got my dz here. Of course, the integral symbol is still here. The only place I have an e to the x left is here. So now saying that the numerator kind of goes away, this is what I meant. It cancels with this piece. And we get 1 over 1 plus z squared dz. Now, who said something about arctangent a minute ago? Who was that?
That was me.
Okay, Chris, beautiful. Remind everybody else, what is the derivative of arctangent of z?
The derivative of arctangent of z?
Yes, sir.
Isn't it just 1 over 1 plus x squared?
Yeah, or in this case, z squared.
Or z squared, yeah.
Yeah, exactly. So that means that the integral of 1 over 1 plus z squared is arctangent of z. Now, I write it as tangent inverse, but it's the same thing, just different notations. And because this is an indefinite integral, we will write our plus z. You could write this as arctan instead of tan with the -1. They mean the same thing. It's not cotangent, right? It's not the reciprocal of tangent. That's not a power. We mean inverse in the same sense that like the square root is the inverse of x squared. That's what we mean here, right? So again, if you're unfamiliar with or haven't practiced with your trig stuff in a while, especially your inverse trig stuff, come back to the review material in the modules and come here to the algebra and trig review. There's lots of stuff about inverse trig functions in here. This is Paul's online notes. It's a really great resource. And if you come down here to inverse trig functions, you can learn all about these. So tan inverse, AKA arctan, is what we're looking at here. We're almost done. Because it is an indefinite integral, the last thing we need to do is go back to the original variable. And now we are done with that thought. And you could check by taking derivatives. Any questions on this guy? Okay. I've got one more for you here today, and then I will let you go. Let's do it like, this. So we have a definite integral from 1 to 3. My integrand, the function I'm integrating, is x times the square root of x minus 1. And of course, my differential is dx. We solved something very similar to this with just the square root before. Now we have an x out front. Remember, I cannot distribute the square root, right? I can rewrite it as a power, but I can't distribute the power. There's no way to make the square root just go to this and just go to this, which means I cannot distribute this x, right? There's no way to rewrite this as a sum or difference of power functions. It would require infinitely many terms. So instead, we need to make a substitution. And just like the first time we saw this guy without the x in front, the trick is to substitute for the inner function here. So I'm going to substitute z equals x minus 1. That will help me handle the weird power coming from the square root. As before, my differential dz is just going to be dx. The derivative of x minus 1 is just 1. So dz is 1 dx. This time it is a definite integral. So in addition to my substitution and differential, I need to change the bounds. So I write down my old bounds. I like to put the lower bound at the bottom and the upper bound at the top. When x is equal to 1, z is equal to 1 minus 1, or 0. And when x is equal to 3, z is equal to 3 minus 1, which is 2. So my old bounds were 1 to 3. My new bounds are 0 to 2. And now we start plugging things into the integral. So my new bounds go from 0 to 2. The x piece, I'm going to leave that alone for now. The square root of x minus 1 becomes the square root of z. dx is just dz. And the question is, what about this guy? All right, I've accounted for all the other pieces. I could just write an x here, but we don't want to mix our variables. We want to have only z's. Right? If there's one thing I need you to remember about substitution, it's that you need to replace every part of your integral with new variable stuff. You should not have any old variables floating around. The bounds need to be replaced by new variable bounds. The differential needs to be replaced by the new variable differential. And the whole integrand needs to be replaced by its equivalent form in terms of the new variable. I've plugged in all the obvious stuff. And I have this x left over, right? So the question is, what goes here? What is the equivalent version of x in terms of z that I should put here in my new integral? Does anybody know how to do this?
Would it be z plus 1?
Beautiful. So we come back here to our substitution. I say, I've got an x left over. I need to rewrite it in terms of z. Well, if z is equal to x minus 1, just add 1 to both sides. That means that z plus 1 is equal to x. Right? I'm just solving this for x. So if you have old variable stuff left over, after plugging all the obvious stuff into your substitution, if you still have an x left over, go back to your substitution and solve it for x. If z is x minus 1, then z plus 1 is equal to x. So this is a parentheses z plus 1 that goes here. Why is this nice? Well, now I can rewrite the square root of z as z to the 1/2 and distribute these pieces. So I get integral 0 to 2, parentheses z plus 1 times z to the 1/2 dz. And now I can distribute. That becomes integral 0 to 2, z times z to the 1/2 plus 1 times z to the 1/2 dz. Z times z to the 1/2 is z to the 3/2, right? You just add the powers. Z to the 1/2 just chilling. What you see me doing here, putting the whole integrand in parentheses, you should do as well, right? Because that dz is multiplying everything. And if you don't write these big parentheses, it just looks like the dz is multiplying the last term. So if your integrand has two pieces separated by addition or subtraction, put the whole thing in parentheses, please. It's just good notation. And the balance here is still 0 to 2. Now I can calculate my antiderivative. Power rule again, z to the 3/2. So if you add 1 to 3/2, you get 5/2. And you could write a divided by 5/2 here, but that's the same as multiplying by 2/5. I'll just write that. Z to the 1/2, adding 1 to 1/2 is 3/2. So this is z to the 3/2 times 2/3, or divided by 3/2 if you prefer. And we need to evaluate this whole expression between our new bounds. Remember, you don't go back to the original variable, you just evaluate this expression from 0 to 2. So I'm going to plug in 2, and then I'll subtract what I get when I plug in 0. So plugging in 2 gives me 2/5 times 2 to the 5/2 plus 2/3 times 2 to the 3/2. Plugging in 0, both of these pieces are 0. So I don't get anything from the lower bound. It all comes from the upper bound. And that's it, you're done. You could factor out a 2 if you wanted. There's a little bit of stuff you could do to clean this up, but I would be perfectly happy with this if you gave it to me on a test. All right, any questions about where any of these pieces are coming from or how we did any of this stuff? Beautiful. All right, then you made it through your first day of Calc 2. There are many more of these coming. There is a homework set open that you need to begin on today. So please get into WebAssign. Remember, even if you don't have your access code, you can get in and get started, and you must. Please get into WebAssign. Please start on that homework today. We want to reboot your brains, right? You guys have been off for 3 weeks. I know it felt like a short break, whatever. Get in, get your brain fired back up, remember this stuff from Calc 1, and start doing it in the slightly more grown-up way that we've talked about here today. So if your Calc 1 teacher said when you do a definite integral, you can plug back in and then use the old bound, don't do that shit, right? Do it like we've done it here. It'll save you time. It'll help you understand better what we're doing later in the semester. And also, if you don't do it this way, I'll take off points on the test. So please get started on that homework set. If you have any problem getting into WebAssign, reach out to me. I can help you. That's it for today. Okay, so please get in there, start working. I'm going to upload this recording so you can rewatch it if you like. Once that video is up, you'll see once you go to my YouTube channel, I've got like 3 or 4 semesters worth of Calc 2 videos you can watch if you want to review anything else. That's it. If you need to get a hold of me, send me a Canvas message. That's the best way. You can also email me. If you email, please put the subject and the class in the subject line. So like say Calc 2 section 4, so I know what you're talking about. But that is it, gang. I've got an office hour today from 1 to 2. So if you want to chat, come to that. Otherwise, I will see you all on Friday. Any questions before we go? Alrighty, then I hope you all have a lovely rest of your day. I'll either see you in office hours on Friday, get started on that homework, and we'll pick it up from here next time. Take care.